There is a story circulating about a digital identity system for the European Union that claims to be ready for prime time. The regulators say it is compliant with the Digital Services Act. They say the technology is sound. But a community of independent engineers on the GitHub platform looked at the same code and flagged it as unfit for deployment. The headline that followed was even more dramatic. It claimed that hackers bypassed the entire verification system in just 2 minutes. This narrative creates a fascinating conflict between the official definition of readiness and the technical reality of security. To understand what is happening here, we have to look past the clickbait and examine the specific vector used to exploit the system. The system in question is the European Digital Identity Wallet. It is designed to allow citizens to prove their age or identity online without revealing unnecessary personal data. The core technology relies on zero-knowledge proofs. This is a cryptographic method where one party can prove to another that a statement is true without revealing any information beyond the validity of the statement itself. In theory, this is perfect for privacy. You can prove you are over 18 without showing your date of birth or your home address. The European Commission reviewed the technical specification and declared the system ready. This means the protocol meets the legal requirements on paper. The math checks out. The encryption is sound. However, the engineers on GitHub found a different problem. They argued that a system can be cryptographically secure and still be practically useless. The disconnect lies in how the wallet interacts with the user and the third-party websites requesting verification. The bypass vector that is discussed in the technical community does not involve breaking the encryption. It does not involve cracking the zero-knowledge proofs. Instead, it exploits the user interface and the flow of data between the wallet and the requesting service. Consider the analogy of a bank vault. The vault itself is built with steel thick enough to withstand a bomb. The locking mechanism is military grade. But imagine if the vault had a side door that opened with a simple password that was printed on a sticky note attached to the handle. The vault is secure in theory, but the implementation is fragile. In the case of the digital identity wallet, the vulnerability often lies in how the verification request is processed by the browser or the application hosting the wallet. The claim of a 2-minute bypass suggests a trivial exploit. This usually means a script injection or a manipulation of the browser's developer tools. If a website requests age verification, it is sending a signal to the wallet. If the wallet is not properly sandboxed, or if the interface allows for arbitrary input, a malicious script could trick the wallet into confirming an age it has not verified. This is not a failure of the cryptography. It is a failure of the execution. It is a UI or UX exploit rather than a cryptographic failure. This highlights a gap between theoretical privacy-preserving design and practical execution. The engineers flagged the repository because they saw that the implementation details left room for these kinds of errors. They believed that mandatory digital identity systems would face continuous erosion of trust and effectiveness due to easily circumventable implementation bugs. When you have a government-mandated system, the stakes are higher. You are not just protecting user data, you are protecting the integrity of a legal framework. If the system can be bypassed in 2 minutes, then the regulatory declaration of readiness is premature. This rapid exploitation demonstrates a broader trend in security. Security flaws in high-stakes government-mandated software are often discovered and exploited by the community faster than official patch cycles can respond. Open-source communities and independent developers are actively creating and sharing bypass tools, such as fake pop-ups or script injections. These tools expose the fragility of mandatory digital identity systems before they are fully deployed. The speed of the bypass is the real story. It shows that the system is vulnerable to trivial UI/UX exploits rather than cryptographic failures. The role of GitHub in this scenario is critical. It serves as the independent validator. While the regulators check boxes and review specifications, the open-source community reviews the actual code. When they flag a project as unfit, they are signaling that the code does not meet the security standards required for deployment. This creates a critical disconnect between regulatory declarations of readiness and independent technical validation. It suggests that without rigorous third-party penetration testing and bug bounty programs prior to launch, these frameworks will remain vulnerable. We must also consider the implications for the future. If a system is declared ready but can be bypassed in minutes, the trust in digital identity erodes. Users may stop using the system because they know it is not secure. Or worse, they may use it thinking they are safe, and their data is compromised. The incident underscores the need for a shift in how we approach software security. It is not enough to say the math works. We must verify that the system works in the wild. The narrative of the 2-minute bypass, whether specific or exaggerated, points to a real problem. It points to the fact that complex age verification protocols are vulnerable to trivial UI/UX exploits. It highlights the gap between theoretical privacy-preserving design and practical execution. The regulators are looking at the architecture. The hackers are looking at the implementation. The engineers on GitHub are looking at the code. All three perspectives are necessary, but they are not always aligned. This situation calls for a new approach to validation. Future implications suggest that without rigorous third-party penetration testing and bug bounty programs prior to launch, mandatory digital identity frameworks will face continuous erosion of trust. We need to move from a model where readiness is declared based on specifications to a model where readiness is proven through community scrutiny and real-world testing. The technology is promising, but the path to deployment must be paved with more than just legal compliance. It must be paved with verified security. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.